Hello and welcome to VitoshAcademy. Today we'll be talking about an old childish game called Tic-Tac-Toe, and this is how it looks like for those who don't remember it. You can win if you are on average, but if you play versus a computer or a skillful player, you can only get a draw or you can lose, which is usually the case. In this case, we have a draw. And although it is really a simple game, it has more than 255,000 combinations, more than that. So a human plays by intuition, computer plays by calculation, as you see. Let's play once more. In the impossible game, as I mentioned, you can only draw if you are good, or you can lose if you don't pay attention to it. So now let's take a look and solve it with Python. Now we are in Visual Studio Code, and I have prepared two functions. The one is called play game, the other one is called print board. And this is what they do. They print the board and they play the game. Let me show you what some interesting part of the code does. I'm just trying it in Python. So this is the board. It is simulated like this. So if you look for the board, it's just empty spaces, and it is 9 of them. As simple as this. User input is actually an input. Let me see what will happen if we make it like this. It asks you to move from 0 to 8 to enter a move. So you enter a move and that's it. If the move is a lower E, it is an exit, so it's good. And then we record the choice. And if the choice is between 0 and 8 and the board is free, we say board choice is X. Let's try it for board choice. I'll write 1 here, and if I ask board, we saw that board for 1 is X. Let's put board for 2, so you get some idea. Yeah, and we have now 2 X's, and pretty much this is the very start of the function. Yeah, let's run the code, Python, and then tic-tac-toe. Now I'm having between 0 and 8, so I write 0. It writes into the board and then it prints it nicely. Somewhere here. So yeah, this is how it goes. 1, 2, then 3, then 4, then 5, then 6, 7, and then 8, and it's full. So I'm writing E, and it's just enough. So there is no artificial intelligence, no intelligence here actually. We're just writing X's on a board, and the code is rather simple. So now let's give it a try and make it a bit more complicated by adding the win logic, so to say. Yeah, I'm going to write this one myself here. So it's going to be called check winner, and board and player. And already I'm getting great options. Like 0, 1, 2 is a win here. Let's see, check winner. Just thinking, yeah. I'm just thinking, okay, check winner, win conditions. Yeah, I just want to. I'm just wondering how to write it. Okay, 2 taps is exactly what we need to write it down. I'm sorry for the debug. Let me see. Okay, win conditions. These are the rows here. The win conditions for the rows. Okay, 3, 4, 5, then 6, 7, 8, then 0, 3, 6 are these ones, 1, 4, 7 is this one, and 2, 5, 8, 2, 5, and 8 is a win condition for the last column. And then of course we get the two diagonals, 0, 4, and 8, and 2, 4, and 6. And then we say for condition in win conditions. And actually this is a bit better than what I have planned to write, but if all board I equals player, for I in condition, return true, else return false. That's great. My idea here was to write it a bit differently. I'm going to write it a bit differently. Or not. Yeah, let's see how I'm going to write it. It's going to be ABC in win condition. Something like this. If board A equals player and board B equals player and board C equals player, then return true, else return false. Well, yeah, player is pretty much what we are passing to is a board. So we have the board, the real one, and the player. And now let's do a quick check, saying implementing the win condition somewhere. Where should we implement it? Definitely not here. Probably somewhere after the exit or in the try. Yeah, this would be good. So choice is the integer somewhere here. Oh, this is good. We should have somewhere like an if check winner, which is a good one. Okay, print board, and somewhere here would be if check winner board and X, then print you win, and then just a break. Yeah, and if is full, I haven't decided this one. Okay, it's just saying it's a draw, and if full is not, so we're gonna make a new function here. Def is full board, and it works. My idea was a bit different. Something like this one, saying whether the space is in the board or not. So check winner, let's see once more. Check winner here is with a board and an X. Great, so player is an X. So if board A is player, pretty much this one, board B is also the player, and board C, which is the third part of the loop, is also an X. So this way we get an X on each one of these. Then it's true. Let's give it a try. And simply start 1, then 4, and then 8, and then 7. And on 7 we got you win. So we can assume that it works, and it would be a good assumption. Yeah, quite good. So in order to appreciate artificial intelligence, we should first see what will happen if we have no artificial intelligence. So in our case, we're just going to import random, and the game would be interesting. So what do we change here? The user input is okay. Yeah, the E is okay. And now the more interesting part. After the printing the board and here, it should be pretty much somewhere here. We should be having the move of the random AI. I'm just going to say something like random AI move. Okay, definitely not with while true. We can say, hey, AI is making a move, or random AI is making a move, because this is random is making a move. Yeah. So first we should find the empty positions. Yeah, this is quite a good option to find it. Eye for eye, spot. Yeah. So if we have empty spots or empty positions, then computer move would be random.choice empty positions, and the board computer move would be 0, and then we would be printing the board. Simple as that one. Yeah, and then we'll be having this one as well. I'm just going to put it here. Let me see. Okay, this one it will be with 0. Yeah, fair enough. And let's play the game again. Okay, this time I'll try to lose, it wouldn't be tough. So 0, 1, then 4, then 3. Yeah, okay, I have to win. And let's try with the other one. So 0, 1. Okay, then something like 7, for example. Okay, 8 would be okay. And with 8 somehow I won? No. The zeros are winning. It should be AI wins. Yeah. Let's try once more, trying not to win. So it's like 0. AI puts a 0 there. Okay, I'm going to try something else, like 4. Okay, 4 was the 5. Yeah. AI won already. Yeah, even the random one, so it's okay. But as you see, if I want to win myself, it's kind of an easy task. I just start with a 4, and then because the computer plays at random, it should be really easy. So 1, 2, 3, 4, 5, 6. This is position number 7, and just pressing number 7 should be 1, 2, 3, 4, 5, 6. Okay, 7. Nope. Position number 6. Yeah, I won. I didn't press 7, I pressed 6. And you see, it's an easy task if you want to win. But the question is, what should we do if we don't want to make it that simple? If you want to make it extremely complicated as far as it's tic-tac-toe, but let's make sure that it's at least as complicated as the tic-tac-toe of Google. And the answer is, let's use advanced algorithms, the ones that are called actually Minimax, which is a famous one. Just to let you know, Minimax doesn't use random, so I'm just going to comment it out or completely delete it and see what we can do there. So the idea of Minimax is to show how a chess grandmaster thinks. They don't look at the board as it is of the chessboard, for example. Forget about tic-tac-toe now. They look in the board as it is in the moment, and they try to calculate what it will become. And this way, let's say that they imagine the best possible moves in a way that these moves are done so well that the next move is the best possible move as well from the opponent. But because of your best possible move, the other move is actually the best possible, delivering none. So let me clarify this a bit more. So I have implemented the two functions that are actually going to make tic-tac-toe from a simple game with random to artificial intelligence. They're called get best move, this one, and Minimax. So what is the idea of Minimax? Minimax pretty much uses recursion and scoring. Here is the base case, pretty much checking the winner. And if the winner is the computer with the O, it returns 1. If the winner is the human with the X, it returns -1. So first we try to maximize the step for the AI or the computer. Let's go with AI. And if we are on the is maximizing, because it also calculates for the person as well, then for the best scores it takes the -1000. Here on the alternative it takes 1000, and for each one of the options it tries and it recalculates the score again up to the end. So it calculates more than 250,000 calculations, which is not so much. And you can be probably actually thinking, hey, what about this one, the other one, get best move? What is it doing? Get best move actually is used here for the AI move, and the best score is -1000, the move is -1. What else should we know about this get best move? Pretty much imagine that it is asking more than 250,000 times per game the following question: if I move here, what will happen? And it doesn't answer, but this type of question actually delegates to Minimax, and then Minimax also simulates the human response. Here you see that's false, and here we have the other Minimax, which is actually true. Yes, so this way we either simulate the one for the player or the one for the computer. Is maximizing is the true one, and if it is minimizing, it is the false one, so to say. So it keeps digging down the tree of possibilities until it hits game over, and it passes the result of +1, -1, or 0. The results were here. Back to the chain. So at the end, get best move compares all the return scores and picks the move with the highest value. Pretty much here, best score. Yeah. And it returns it here. You see, it's for all the loops with recursion, best score. This is the comparison that is done, and this is the end of the recursion. I mean, this Minimax is actually considered two functions, one for the AI and one for the player, but instead of writing two, we just have one flag that we are just saying, hey, are we going to maximize or not? Simple as that. Let's play, and this time when we will be playing, the only thing that we can do is pretty much having a draw. So let's start with 4, and then start with, this is 0, 1, 2, start with 2. And if I don't write it here, I'm going to lose the game, but 1, 0, 1, 2, this is 3. And whatever we write now, it's, yeah, going to be a draw. Let's write 8. And let's try to lose once now. So 1, then 2. Okay, not so easy. But okay, I'm going to, yeah. It's instead of beating me, actually, that's interesting, it decided to continue in the game, but this time it's actually obviously that the tic-tac-toe is going to win. So yeah, I mean, I'm going to lose this one, and that's it. The AI won. Although it's not exactly an AI, it's just recursion with rules and Minimax, but so to say, you can consider it winning. I hope that you like the video so far. I hope that you like this way of writing code into Python. If you don't like it, you can fix it a bit like this, and then like that. You see, the semicolon stands for new line, forcing it. So say I can write here, break. Control Z is going to fix it. Yeah. Okay. So far so good. And I hope you enjoyed this quick VitoshAcademy video, and in general all the other videos. And that's all from me now. Enjoy the rest of your day. Take care. Like and subscribe. Goodbye.